file which I have sent you previously. So you can download, you can open that file. You know all the steps. Now I think you are familiar with this code. You can go quickly change the directories and you can quickly activate the normal file. You can quickly load Retrieval app. Okay, last time we were discussing about this thing. For this one, we use the Boy dataset for the visualization. We use this data, and then we also learned about this NDBC web data guide and the NDBC web data connector. So if you click here, you can get the document. If you click NDBC web data guide, you can get a document, sample document of using how you can use this NDBC connector and how to access data using this one. So you can click and download that file also. So here is that file. So if you go through this file, you can see table of content is not here. Yeah, the table of content is here. You can see you have a lot of data, like how you can access the data and how you can use this data set. So you can read this one for more information about this connector. Here we are using, like here we are using this siphon NDBC connector. So if you need to know more about this connector, you can learn about more by using that thing. Otherwise, you can go to the Siphon official website and search for that web connector. So if I go here, it shows, because this one you can access different type of data, like especially this is targeting this buoyancy data, and also we have you can access some NCSS data. Even you can access those data, and even you have some sample codes over here. So if you go here, they provide you some sample how you can use Siphon to access this data without downloading it into your PC. Typically, you are downloading the data file into your PC and then you are going ahead with the analyze. But there are some methods, like you don't need to download the data. While the data is on the servers, you can access those data and do the calculation by using your PC. So these are some example codes. So you can follow these examples also. Here you have the Jupyter notebook and also the Python file. You can download these examples and try to modify those things and try to make use of this library also. Then we discuss about okay, we connect this data, we load this NDBC connector, then from that NDBC connector we access sample site data. I think over here near Los Angeles we access the station number, which one? This one was some station near close to this area. So we are accessing that data and checking whether the data is available. Then these are all the commands that you can use with this NDBC web connector. Then we loaded this data into a data frame using this command. So here we load the data and import it in to our data set. Now I am getting this error. Why? Can someone say why I am getting this error? What's the issue? Because here I am using this NDBC connector, but you can see this is my first run. That means the first execution, but I didn't import these files first, so I have to import these things first. So since we are accessing the data without downloading them, that's why it's taking some time to get the data. If your internet connection is much faster, then it will be uh, run without taking that much time. But right now we are accessing using, IMSA. That's why it's taking some time. So you guys also need to run these things again. Okay, now I will access the data set of this station ID 46407. So now if I need to view the data, I can use this df command. So it will give me the last few records of this station data. That means I have around 6,464 data for that specific station. These data are real-time observations because you can see the time in here. You can see the time. So these data are real time. You are accessing the real time. That boy is in the sea and you are accessing it from using your PC. So these data are real time data. So to view the data set, we use this command. Your data set name, then info. So what will happen? It will give you this information regarding your data. So here you can find how many columns you have and whether there's null data or values are there and the data type of each column. So you can see here we have 15 columns and the last column is date and type. The rest of the things are this kind of data. So now after that, we need to drop all the columns. We know if you we discuss about this command, what we use drop pending. Can someone say? If you attend the previous xarray course, we discuss about this one. What do we use drop pending for? What's the meaning of this one? We discuss about this drop pending. Even the guys who join online, they also can answer. So what's the purpose of this drop pending command? So what will it do? So it will remove. That means I'm going to remove something. Even I can remove columns or rows. Right now I am specifying, okay, the axis is column. That means I need to remove the columns where it contains, there's no any value. If there's no any value in the entire column, just remove it. Remove that column. So here without running this one, if I view the DF info, you can see I have 14 columns, 15 columns. That means 0 to 14, that means 15 columns. So after I execute this one and view the DF info, you can see now the column count is reduced to 30. That means 2 columns are there where there's no any values. So we don't need those values for our calculation. So because if there's no values for those two data, it's not needed. So we need to remove those things before we go with the calculations. Otherwise, if we incorporate those data into our code, it will take some time to execute. So then we can view the data frame by using df. Then you can see, as now you see, we have 6,400, around 6,500 rows for this data. And if you view the first data, the time of the first data, so if you view the time of the first column, you can see the data is from 2024, 5th, and then the 10th. That means actually it's taken from today. Data is taken from today. That's why I'm talking like you are accessing the real-time data. So then we discuss about this one. So how we can get you, how you can retrieve any station data from there, because this is the station network. So this is the buoy station network where the NOAA, these guys install these buoys for, like, especially for the oceanography. They need to check what's going on the ocean. They deploy some buoys all around the world. with the collaboration of different departments. If you go here, you can see we have different universities and different departments, even meteorological bureaus, and we have a lot of bureaus around the world. So those guys are there to maintain those buoys. So you can access any data from this data set. If you go into the below part of this one, you can see stations with the recent data, and also we have some inactive stations. So now you know, just imagine if I need to access the data of this station, how I can modify my code. So here I know the station ID 13002. So how I can access that station's data? So that's why I put some example like that. If you understand the code in here, you know this is the place where you need to change. So here is the station ID. If you change this station ID into a specific station that you like to check this data, you can change into that station ID. And then you can check whether there are data, like whether there are data for a specific purpose. If you are using checking on the wind direction or with the wind speed or the wave height or something, you can check from here. So that's how you can access the stations. Then we discuss about okay, then we load the pandas, because now for our specific purpose, we are going to extract only the recent data. Like we are imported the pandas as CD. Then in the panda, we have timestamp, a library called timestamp. If you load this timestamp library and UTC now, it will take the time from your PC. Because here I have the time in my PC, it will access this time with the time zone. So it will get the current time from your PC. So that's what this code do. So it's accessing the current time and then subtracting 7 days from that exact time period. That means 7 days ago. So now I have the time range. So I need to have the past week data. So now I'm going to subset my actual data into the past week data set. So here you can see the time state. So if I go like 7 days back with the according to my day and time, so this is the day and time I should look for. So from there, now I am going to subset. So here I am doing IDX DF time where equal or greater than DF time. That means all the data which are recorded after this time state. So here I am filtering my data set. So let imagine, okay, we need to check like past month, how we can modify this one. So here we need to change the days. So whether if you like 10 days or something, you need a specific days, you can change here. Then it will retrieve the data after that exact point. So then we can view the data set. If we view the data and the head, we can see. So these are all the data recorded during that time. So here I'm using like df head. So if you use df head command, what will happen? It will only show the first 5 records. If I remove this df head and view the entire data set, it will show me all the data within that specific time period. So if I go into the time column, you can see 2024 May 3rd. From this time to the current time zone, I have the data. So now I extract the data. That means in the original data, I have around 6,400 rows. Now I subset it to according to my need, because I only need to check the recent condition in the ocean. So I subset that one into 1,000 rows. Now I can play with this data. The first thing is, if you go here, you can see the index is messed up. So now we need to reset our index. So we discuss about this one. What will this do? DF reset index. That means, so when we discussing about Panda data frame, we discuss the data frame, we have indexes and the values. So index is there to access a certain row or something. We need to know about the index number. So right now what we are doing is we are deleting this entire index row and resetting the order like 0, 1, 2, 3. If it is messed up, we are deleting the entire index and re-indexing. So that's what we do in here. And then we view the first few records in our data set. Then we go for the plotting. So here we are using matplotlib. We will discuss about this one in detail. But if I don't know whether I will have enough time for that thing or not. But you need to know about some things regarding plotting. So that's why I like try to include like plotting and different libraries together. So this is the plot that we need to import whenever we going for a plot. Not a spatial plot, like if you are going for a typical plot like time series or blocks or box plot or then pie chart or something like that, we have to use matplotlib. So this is coming from MATLAB. If you familiar with MATLAB, this one comes with from the MATLAB. So you can view about this matplotlib library also. If you copy this one and search in your browser, you can find a lot of details regarding this library. So here is for the visualization with the Python. So if you go into here, you have different plot types, user guide, tutorials, examples, and a lot of details are there. If you need to know more info regarding anything, you can access these websites. Because at the beginning also, I encourage you, whenever you see a new library, just try to find out whether there's a support website or something for that specific library. Because you can go there and everything is there. So even their latest releases, and if they have like references and the examples or the tutorials, you can go there and check. If you go into the example section, you will find a lot of examples. That means you can directly download that code and you can customize according to your need. So here we have different type of charts, even animations and 3D plotting, and different type, like if you need to change the units or the tick marks, even for those things, there are some codes. So if you click here, it will load the entire code, the Jupyter notebook, how you can modify these things. So you can read this thing and you can download, even you can download this Jupyter notebook and try to play with this one. Because the best thing is you need to do everything by yourself. Whatever the weight that you are putting in for the learning, then you will get output. So you have to go through these libraries also and check. So the basic thing is we need to import this plot. So we are importing from matplotlib, we are importing the pyplot. There's a plot called pyplot. If we go into this one, there's a module called pyplot. So I can copy this entire command and I can check details regarding the pyplot. So if I need to know about this one, I can copy and paste. So it will give me the detailed information regarding this pipeline. So how I can use this one. Even there are some examples, and also we have some custom examples. Also, and there are the more functions that we can use along with this one. So here, the first line is to load the matplot library. That means the library we need for the plotting. Then the second one is we are setting up. Now we need to view whatever the map we are preparing when we executed right after under in the lines. So if we need to open these maps in the Jupyter notebook, we have to run this magic command. Actually, this is a magic command. You need to use this magic command if you need to view. So you don't need to know about this thing, but you need to type this one in the same way, exact way. So it will activate the use of matplotlib alongside with the Jupyter notebook. Okay, now we are going for the actual plot. This one is for our plot. Now you need to know about this one. Plot RC mean whatever the thing like globally. If it is the thing like the font size or the colors, color ramps or whatever the thing that you are going to use for your specific plot, we can mention using plot RC. You can check this one also like PLT RC. What will this mean? So if I paste it in here and check, so it will give me regarding this specific library. That means matplotlib pyplot RC. So if I go over here, they mentioned this is the current RC param for group or grouping RC. That means grouping the resources. Like if I have the line chart, I can specify, okay, this is the line width. If I have multiple lines in my plot, all the lines should be in this width. And these lines color should be in this color. So I can specify like the command. So it will affect for all the lines and whatever the things inside your chart. So you can see, even if you need to have a custom font, we can specify even the font family and whether the font is in bold or italic or something, we can specify those things also. But in this example, I only use the font size. So what will it do? So for whenever if I create a plot using the PLT command, then it will affect, like for the plot, the font size will be, by default, the font size will be 12. So if I need to increase the font size, this is the place I can increase the font size. So then we need to open the plot, the actual plot. So if you familiar with NCL, during the NCL lecture also we code, like before you go for the plot, we need to load the workspace. That means where are the place that we are going to put the graph. So here what we'll do, we are preparing the plot, the actual plot. We are not loading the data or anything. We are creating the grid and the plot. Just an entry plot like this. So now what we are doing, here we creating from the PLT, there's a command called subplot. We need to load a subplot for our specific plot, and this plot should be in this size. That means 10 units and 6, the 10 units in width and 6 units in height. So if I type like 10, what will be the typical size of this command? Will be like this one. The plot will be like this. If I use 10, the plot will be like something like this. So now we are just doing that thing from here. Even we can type like 10.4. What will happen if you type like 10.4? Then the plot will be like this. Just because you have like 10 units from here to here, you have 10 units. 1, 2, 3, 4, 5. Likewise, you have 10 units. So if you type like 4, the size of your plot will be like this. So here we are just specifying the plotting area, the size of our plot. Then after that, we need to actually put data inside into this plot that we have created. For that thing, we have to use this one, because we make, okay, AX equal plot. That means the name of our plot will be AX. So whenever if I need to put something into this plot will be accessed by using the name AX. So whenever I need to put some data into this plot, I have to use AX dot something like that. So then it will understand. Just imagine, for this one I use AX, and for this one I can use AX1 or plot 1 or anything I can use. But you need to remember, if I need to access this, if I need to put something in this plot, I have to use AX. If I need to put some data into this plot, I have to use plot or AX, whatever the name that I have given. So here we are adding some data, then we are using this plot command, plot function. So if we use the plot function, I told you about this one, how we can view the doctrine about this AX.plot. So what are the arguments that we need to pass? You can type shift and tab in your PC. So you can type shift tab. So it's not coming. Or you can copy this entire thing and paste it in here, search. Other thing is, like, you can copy the x.plot part and you can search regarding this one. So I am accessing plot. So in here, if I go into this command, so you can view the use of this plot command. So you see, it is to plot y versus x line or markers. So what will this function do? If we have x data and y data, it will plot a line or a marker plot. Like if you need to put some points, you can make a marker or line plot. So that's why we use this plot function. Then we need to know about how we can pass the data inside into this function. So here they provide, okay, if you need to pass some values into this plot, you need to type like Ax, then your plot, then X values, and then Y values. So either you can use this one. Then if you need to use some markers like circle marker or triangle, you know about these things. If you read the literature review, you can find like there are some plots with cross marks and with the line, and also some circles, and also some like box markers or something like that we have with along with the line. So if you need to have something like that, you have to type the command like that. So what will this BO do? Like you have to view. You can go into the bottom section and check like what are the markers that you can use. Here you have the characters for the markers. So if you need to make a point marker, you have to use this character. So if you need to make a pixel marker, you have to use this character. So if you need to make a circle, triangle, or any sort of other marker, you have to use these characters.
I'm in class.
So that's why I'm encouraging you to visit
I'm in
this
training. I need a
reference site. Like
certificate.
they are
Thank you,
websites.
sir, to
So
give
in
me a
the website, they
certificate
mention
to
about
carry.
everything. So that's how you can create a plot
But I studied
with
too much.
these markers.
Nice enough.
Then the next example,
Yeah, I know.
if you go into the next example, we have the other ways. Now we know how to pass the values. First we need to pass the X values, then we need to pass Y values. So now if we go into our command, we know if we need to pass some data, we need to use Ax plot. After that we have to pass our X values. Here I am going to plot wind speed against time. So my x-axis will be time and my y-axis will be wind speed. So from my data, how I can access time? We discussed about this one previously. So df, my actual data, the variable name of my actual data is df, the data frame. If I put this tick mark over here, I can view all of my variables. So my data set name, data frame name is df. So in my data frame, I have all these variables. So then I have to put, okay, from df, then dot select type. I have one column, that means a series called type. So that's the data I need to use as my y-axis. Then after that, I need to put comma. Then I have to specify the x-axis, the y-axis. Then for the y-axis, I am going to use wind speed. So then df dot wind speed, because I have a variable like series named wind speed.
So you will just write the plot, you don't put PDF, just say plot time, wind speed. You get the result.
No, we cannot get the result. Like for the x, we need to select the data. So let me load the code from the above. Like I can type df. So then I can view my data frame. So from in the data frame, you can see these are my column names. And if I type df.info, you can see these are all the columns that I have. So these are the corresponding column names. So if I need to access all the time data, we discuss about this one. What will be the command if I need to access all the data related to the time? So I can type df.time. And if I execute this one, what will happen? So here you can see all the time steps are extracted as a series. Over here also, if I extracted this one into a time, otherwise you can use it like this. Import into a different variable called time. Then if I execute this one, a series is created. So in this side, a series is created as type. So it's not minimizing. Okay. From data frame, if I minimize, I have a standard data series called type. Then also for the wind speed, I can load that into a separate variable as wind speed or some whatever the variable name. Then from data frame dot wind speed. So I can copy. The simple thing is I can copy the wind speed from here and paste. Otherwise, it will become like some typo errors. Best thing is like you can copy Just view the columns and then you can copy the column name. So now I have two series, name time and WS. If you like it this way, then you can use this one as time and TS. It's because I have two different series over there. Otherwise, you have to put like this. If you extract a time and WS for two different time series into two different time series, then you can type those two over here. Otherwise, you have to access using this command. So the both things are similar. Here you can see there's no difference. Both they are similar. Like this one is an addition, excess. So then we have to specify. Okay, then we display x and y. We display the x and y. Then if I remove this part and execute the command, it will float. So if I remove this part and try to execute this command, so it will float. You can see the data is floating, but I need to make some customization for this one. So now I need to know, okay, how I can change the color of this one. Instead of using this blue color, I need to use different color. So how I can use those things? So then I can specify. First thing is X and Y. Then after that, you can specify whatever the other things that you like for this flow. So for that thing, I can use, okay, there's a variable name color. If I go into here, they specify like other keywords. So other keywords, for the other keywords, these are all the other keywords that you can use for this one, along with this plot command. So in this plot command, there's a command called color. So it actually representing the color for this specific series. So if I need to assign a different color, I can use this one. Even I need to make some dash style line, I can use one of these two commands. So these are all the other keywords that I can pass along with data frame. For here, I am using the color, that means the orange color. Otherwise, you can use hex codes. If you are familiar with the hex color code, you can use a hex code. Otherwise, you can use typical names for different colors. Here I am using like, okay, this series should be in orange color. And then I am labeling this wind speed. You cannot see the main purpose of this one. Why I label this series? What's the main purpose of labeling this series? Just imagine if you putting like two different or multiple series in the same plot, then you need to put a legend. If you put the legend, you need to know what does this each line mean. That's why we are labeling this line. So if we put a legend, this name will appear in the legend. That's why we labeling this as label equal wind speed. In here also we have that command. If we go into the other keywords, we have over here we have, that means we are going to label this object or this time series. So then our time series will be labeled at wind speed. Then we are customizing. If I execute this the code without these things, you can see a simple plot will appear, but nothing is customized. Now we don't see x-axis is labeled and y-axis is not labeled. Even we don't have a title and we don't have legend. Now we need to add those things also. And if we need to add grid lines, we need to add grid lines also. Yeah. Let me. Yeah, if we discuss about this one individually, this one will, if you focus about, let me go for the first one. For this one, what's the purpose? This one is the global dataset. Like if you need to add all these things like global for the entire series or the entire plot, whatever the things like, okay, this plot should be in this font size. And this plot, the font that you, if you, when you create in this plot, you need to use this font type. Even you can specify the font type. Whatever the thing, except like for this plot global, you can put those things. Then this command is be creating the empty plot. There's no any data. We are just creating an empty plot. After we load the empty plot, then we put this series into that plot. So that's the order that we are going for. Just imagine if I need I can remove this line also. So instead of this one, if I remove this entire thing and execute, what will happen? You can see there's an empty workspace, and even these axes are labeled like this. You can see we only have an empty plot. Now we need to add data into this plot. That's what this command do. So if I remove these things and run this one, now you can see the plot is there, and we have the time values, the 7 time values, and the values like the wind speed values. But we know, okay, this axis names the wind speed, and this axis represents the time. And if I'm going to present this one into someone, I cannot use this graph. I need to make some customizations. Then I need to know, okay, how I can add a title, how I can label the x-axis, how I can label the y-axis, those things. So for the labeling, we are using this one. There's a command. We call like, whenever I need to access that plot, the command is AX. So AX dot set X label. That means I need to label my X axis. After that, within bracket, I can specify, okay, this X axis is type. Then, okay, then the X set Y label. Then I am setting my Y label. That means this axis. I am labeling this axis. This axis should be in wind speed. Then I have to label, I have to set the title for this plot. You know about this plot. The name for this plot we give is AX. Then AX dot set title. These data are buoy wind data. Then if you need to view the grid for your plot, you can type like ax.grid equal true. By default, it will be false, but you need to enable the grid lines. You need to type ax.grid true. Then whenever you need to access add the legend into your data set, you can see what does this mean, like place a legend on the axis. So now after that the legend will appear. Now then we need to say, okay, this legend should be appear in this specific area in the chart. So there are by default places that you can use. So if we go into the doctrine of this one and go into the bottom part, you have these options. For the location, you can choose these locations. That means the best location. So it will automatically locate the access for you whenever it will check. Otherwise, you can say, okay, this legend should be appear in upper right corner. If you need to make the legend in the upper left corner, you have to use upper left. Otherwise, you can use this location code also. It's also fine. So both it will understand the board. Now, if we execute this one, you can see even the time axis is there, the axis is here, wind speed is there, and the title is there, and the wind speed also labeled like this. So if I need to change this location into a center or the left, upper right, what will be the command? If I need to put this legend in the upper right, what will be the command? So where should I change? If I need to change the legend into the right side, what will be the command? Otherwise, if I need to appear this legend in this place, what will be the command? So here you can view the doctrine, just view the doctrine and go into the bottom section. And you can copy the entire place, like whatever the place. If you need to appear in the lower left, you can copy this command and you can paste it in here. The simplest thing is that you don't need to recall these things one by one. So if you type like lower left, it will appear over here. So that's why I'm even talking about like view the doctrine, shift tab, you can view the doctrine for that specific function. From the doctrine, you will see a lot of things, even the examples. It's okay. Even I can put any name in here. Just imagine if I type like plot or something. So that's the name I given for my plot.
So for example, I decide maybe instead of AX, maybe I can say that.
Yeah, it's okay. But you need to omit the typical keywords that you are using by default in the Python. You have to remove those keywords. You have to make sure it's not like a typical command in the Python. Otherwise, you cannot use the same, like if you have a data set named as data, you imported some data into a data frame or something. You cannot use this same name for the plot also because it will become confused. So you have to give a different name. So if you give your chart name in here as AX1, then what will happen? If I type it like this and if I try to execute this one, see, it's two different plots. Now it's not understanding. I am like accessing AX, but my actual plot name is AX1. So it will be two different plots. If I type like, okay, this one is AX1, now it will understand up to here. You will see. Okay, see. Now it's appearing like this, but the rest of these things are not added into that plot.
So if I have two data sets together,
Yeah.
I have to find the AX1, AX2.
Yeah, if you need two different plots, you have to do it like that. So if you need to put into a same plot, you can use the same command. We will add another plot into this axis after that. So okay, now this one is okay. Now there's an issue in this time axis. If you see in this time axis, it's not clear. It's not clear. So we know these are the recent data. So it's belong to year 2024. So instead of using like 2024, we can remove the 2024 part and we can label this one as 5, then 1, the May 1, May 4, like that. We can label this axis. So how we can do that thing? So this one is like for the customization, we can remove this one. It's no needed. This one is no needed. So the next thing is how we can customize these axes. So how we can customize those labels. So next thing is that specific thing. For that thing, we need to load something called day locator. We need to load that day locator. So in the matplotlib, we have a library called date. So if you load this one, it will understand about all the date formatters over there. Like we can format the dates like 2024. Then we have something called May, then 01. This one for me. And also we have 2024, then 5, 1. This is another form. And also we have 2024. Instead of this data, we have this diagram. Likewise, we have different date formats. So if we load this library, it will help us to identify all of these different formats. All the formats are there. That's why we load this matplotlib dates library. So you can view about this one also. You can search it in Google and then it will appear. So here, if you load the dates, here you have the locator and the formatter. So the main purpose of the locator is to locate the date. It will auto recognize the date and those kind of things. So if we need to say, okay, this axis is dates, then just identify the date format of this axis. So then it will understand this format, like this dates are in this format. Then we can use the formatter to customize the identified format. That's why we need to use this both, like locator and the formatter. That's why we load date formatter and the day locator. Then the first thing is we need to locate the x-axis or locate the data, the time data. So in our axis, the time series are located in x-axis. So we need to set, okay, the set major locator as this axis. So now it will understand, okay, this x-axis is formatted in this date format. So now it will understand, even if I execute this one, you cannot see any major difference. But now in the background, it knows this x-axis is in this exact date format. Now we can do any customization for this date axis. Okay. Then for the customization, we can use then for the major axis formatter, date formatter, month, and the date days. These are different formatters that we can use with the date formatter. So now I am formatting the date according to months, then slash days. Now that axis will be formatted into this specific format. So if I execute this one, now you will see it's changed. So now you need to know about these different formats that you can use. For that thing, you can use this search for this date formatter. So you can copy this one from here, dates, then dot date formatter. So this is the library that we are accessing. So if we go into the date formatter class, they will show you some examples how you can format days in different ways. Like even date formatter can access, like if you need to have like years, then months, then days, then hours, minutes, seconds. So this will be the format. If you need to change the format. If you go, we don't have something. I will try to find like different date formats. This one and put it into a table. So it will be much more easy. So we have different date formats. We can use yeah, I will give you some, I will find some document and upload it into the WeChat group. So here is my month. If I use like %m, then it will appear only the month. Instead of the name of the month, it will show you the number, the exact number of the month. Then I put dash, then separate the days by using this dash mark and then show the days. So now you can see this axis is customized. Now the next thing is how we can add another data set into our data. This is specific flow. Just imagine we need to view. Right now we look in the wind speed. If we need to view the wind gust also, how we can add the wind gust into this flow? If you need to have 10 days. Yeah, if you need to increase the 10 days, we discuss. Right now, we shorten this data into 7 days. If you need to do the plot for 7 days, you have to do the subsetting early. You need to format the axis. Instead of showing the each days in this axis, you need to custom format, like the intervals. So for that thing also, you can format the x-axis. So if you go into the x-axis, so here, when you setting the x-axis, we have some other command. So for that thing, we can use this one. Whenever you need to change the x-axis interval, we have some some commands for the frequency. That means you are changing the frequency of the specific x-axis. So here you can type x-ticks. So this is the command that you have to use. So these guys use something called PLT, but right now we are using AX. Whenever we need to make the interval, this is the command x-ticks. So you can search with matplotlib pyplot, then x-ticks. So if you search for this one, you can go here and it will show you how you can customize these tick marks. So if you need to have interval, you can set the major and minor. So you can customize. Here you can specify the range. Then the NP arrange mean it will automatically detect the maximum value and the smallest value in your data set. And then you can specify the step. Step equals 0.2 mean every 0.2 it will be having something. Like for this specific example, we can type step equal 7 or 2. Then if we need like not the day by day, if you need like 2 days in the axis, we can specify like step like this. For that thing, you have to use x-ticks. That's the command. So if you need to have the different time interval, you have to use this x-ticks. So it will understand that command. So the next thing is we need to access at the wind gust. So if you understand how we can access the x-ticks into the same graph. So here is the command, like the same command we are accessing. We need to put this series into the same plot, the AX plot, not into a separate plot. That's why we use AX dot plot. Then for the x-axis we are using time, and then for the y-axis we need to show the wind gust, and then the color is in green, then the line is type. We discussed about this one also. Instead of showing a typical line, you can use some dash lines. So it will appear in the dash line with the green, and then we can label this one as wind gust. Then we need to show the legend again, because if you didn't show the legend again, what will happen? If I remove this one and run this command, what will happen? So here you can see only the wind speed is there, but the legend is not appearing. That means I need, because I have added the series after I show in the plot, after I show in the legend. So first thing is like you need to give all the series first, and after that you need to show the legend. Then I will run this command. So it will appear the legend in the upper left corner. So okay, now you have a task. Try to do this one quickly. So instead of creating AX, you can create a separate plot as my AX, and then you can create the same exact plot and try to display the day, like time series. In the temperature, we have like the place called like air temperature. You can try to show air temperature along the time in your plot. Try to create a plot using the above learned things. Try to create a plot in this size and add air temperature into your plot, and then try to format this one according to this specific format, like September, then the days. For this one, you can use this table of formatters. So this is the place that I forget this one. Okay, here you can find the different formats. You can try to do it quickly. Just try to create the plot. The final graph will be look like this. You need to create a graph like this. From that specific station, you need to extract the temperature data, and you have to plot it like this. So you know all the codes that you need to use for this specific task. Try to create this specific flow. So just copy and paste. In the previous test, we have all the commands for this one. Now you need to modify this one. So here is that table. So if you need to have like weekend days, percentage A, like Sunday, Monday, Saturday. So if you need to have like a date format like in 01, 02 up to 31, you can use percentage D. If you need to have the month names, then you can use percentage B. If you need to have the month scale, like the full name of the entire month, you can use percentage capital B. So it will appear the full name. Then if you need to use only the decimal numbers for the specific month, you can use percentage M. And if you need to view the entire year, like instead of using the entire year, only the last two digits, you can use percentage simple Y. For the percentage capital Y, it will be the all the four digits for that specific year. So if you need to have hours also in your date, like time series or X series or Y series, you can use this percentage H. So this is that specific chart you need to know about. So you can access this one, the date formatter. So it will have all the necessary commands you need to know when you are formatting the date. You can try to create this plot quickly as possible because we have to move on. Because we have all the necessary commands, so yeah, create that quickly. Just to think of that. So understand and so here you have to create a different float, not the eggs. Here I'm marking like for the float name you have to use this one. For the float name you can use this one. My figure, my AX. Instead of AX, you have to use my AX. So right click before clicking. So it is not a main task. Now you need to know where you need to change. First thing we need to create the float. So we discuss where we have that exact line to create this float. So I am asking you to create a float. Because the thing is you need to create the float anymore, right? Both sides, and then you have to set the float, and then you have to add the data to your specific float as a thing. Then you have to format X and Y. Labels and headings and those things you need to label. So these are basics, like it will go to the these things are basic.
Yes. Oh.
Okay, for the first line, I can copy this entire thing. For the simply, I can copy this entire thing. I am asking you to create a plot with this data. So the first will be this comma. Then you created the empty plot display. Yeah, I'm format. One axis. You need format the one axis like September, then the date. Now instead of using 5 parameters, the actual one name and then the date. So we discussed about this one regarding like format. How to use the date format. How we format this one. Here, like this one. We format days according to this one. Like we did the one what day. So how we can use this format. Yeah, I will format is okay to use this one. This are the products. Yeah. So if you know these things, you can find even code from somewhere else and you can extract the things that you need for this specific purpose. Now let's mistake. What's the mistake? Now here you are defining four line A's. What you are plotting here is my A's. No A's. Okay, for this specific thing, I can copy the entire thing. I can copy this entire thing. It's easy. I can copy this entire thing. Let me copy this entire thing. And I can paste here and I need to do the customization. After that, I need to do the customization. Here I am asking instead of plot, use my plot. So I can rename this one as my figure. Then the axis is my plot name is my AX. Then AX instead of AX I have to use my AX. My AX plot, then DF type and then data frame. If I don't know about my data frame, how I can view the data frame? I can type df dot info. So I can type df info and view the information regarding my data. Here I am asking you to put air temperature against type. So I will select air temperature instead of the second. That means my y-axis I will choose the air temperature data. That means df air temperature. Then the color for this one I am asking you to put you can put like blue color or something. Yeah, I'm not asking you. Yeah, the blue dash lines. Blue dash lines. So it's easy if you understand. So the color will be blue. Then the labels for this one it will be air temperature. Then I need to format my X, then the set X label is time, then my X, set Y label will be instead of wind speed, it will be air temperature, And then for AX, the title, this one will be, you can type whatever thing like my AX, then your title. Air temperature, plot or something you can specify, whatever the title you like. Then my AX, I need to show the grid, and then my AX legend should be appear in the lower left corner. So the other things I'm mentioning is I need to format. If I execute this one, I can see this plot. Their temperature is like this. But I am asking you to format this axis according to this format, like May, then the date. So now I need to do the formatting for this one, and also I need to use dash lines. Here I am not using a dash line. So how I can use the dash line? Now I need to know, I need to convert instead of a single line, I have to use dash, and then I have to use this date format. So for that thing, I know here, from here, where I make the date formats. So these are the two lines that I have used for the date formats. So I have to use these two lines. So I can copy that thing. And paste it over here. Now I need to specify this one is not AX, it's my AX, and this one also my AX, and then x-axis major locator, then the day locator, then the date format. Here I am asking not the month. So if I go into the date formats, if I need to have like short month names, so from here I can find that one. For the short months, I have to use %B. So I can copy this %B from that place and put it over here. Now, instead of this mark, I am using the dash, then my days. So if I execute this one, you can see this axis is formatted accordingly. Now I need to convert it into the dash. This for the middle, like month should be in this format and the day should be in this format. Within that thing, there should be a dash separator. Then I need to convert this one into the dash lines. So if I need to convert this one into the dash line, then I have to specify the line style. So I can set the line style. Here if I put a line style as dash, now if I try to execute this one, you can see now I have the temperature in the dash line. So it's easy. If you understand the code, you just need to do the modifiers accordingly.
Yeah, it's.
Yeah, also you can do this thing.
Yeah.
if you need to rotate this axis, like instead of May, now you need to rotate these things, like instead of May that 4, now you need to rotate this one into this format 0 2. How you can rotate this one? You need to rotate the labels. Sometimes you have to rotate the labels, like if you have the long dates, but you need to have the exact year now and then the exact days and the months. So how you can rotate those things? So there's a different command for this one, tick parameters. So if you specify the tick parameters, you can specify the rotation. So here they specify the label rotation. So you have to use this tick params command. That means you have to use this tick params. That means you have to type my ax dot tick underscore params. Then within bracket you have to specify axis equal x, then the label rotation. So I go into this tick params, then I have to specify the axis using axis command. Then it will be like x o y o. Then if I need to do the both, then I can use both. Then I have to use the other thing is label rotation. This command I have to use this label rotation command. Label rotation equal. Then I have to specify, okay, 90 degrees. Then I have to close this one and I have to execute. So here. Here I deleted the bracket. That's the issue. So here you can see I deleted the bracket. I didn't see the command in here is mentioned like undetermined string literature. That means I have accidentally deleted this one, so I can close this one. Can execute this one. So now you can see this one is rotated. If you need 45 degrees, here you can specify it as 45. If I 45, you can see it's rotated into 45. For that thing, you have to use this tick params. So in the pipeload, there's a thing called tick params. You can use this tick params. That means tick parameters. Whatever the parameters you're doing for the tick marks, you can use this tick parameters. Okay, now you know how you can do that thing. Then the next thing is you see some graphs with multiple y-axis. You use the same plot, but you have two different y-axis in the same plot. It's like label. This side of y-axis is for another data set, and this side of y-axis is for another data set. And it's having a common time axis. Yeah, twin y-axis. So how you can make this twin y-axis graph? That means you can put like two different series for this y-axis and one series for this axis. So if you have multiple axis for this one also, you can put data. So now you need to know about that thing also. So how we can do it like that? Okay, just imagine I need to put the pressure data also in my AX plot, not my AX plot, for the previous plot, you know. For the AX, now I am going to put my third series. So my third series will be pressure. So now I am going to put third series as pressure into my plot. So if I put this one, now you can see I have three different data here. Pressure, then the wind speed, and then the wind gust. I think wind gust appears twice. It's because so let me reset this panel. I can start run all sales. Okay, now you can see three charts are there, but the issue is here is sharing the same axis. For the pressure, we have 1000, and also for the temperature and the wind gust, we only have 0 to 10 or 20, something like that. If we go for this, the above plot, we can see the temperature and the wind speed and the wind gust is varying between 20. But if we put the pressure has like 1000. So that's why we can see a chart like this. Now we need to know, okay, for the pressure, we can use the second axis. Or otherwise, we can use these two graphs as in the second axis. So how we can do that customization? So here you know how we can add the third series. So the typical way is like your plot name, then plot df, then your x data, and then the y data, then the color of your plot and the label. So then the next thing is we need to enable the TwinX. So this is the command. When you create in the plot, first you need to load plot, and then you have to enable. Okay, for the AX, then at B, AXB mean the secondary axis of AX plot. That means AX dot twin X. That means it will enable the secondary axis, and the secondary axis will be AXB, not the AX. So then we have to set, okay, for the X, set the time, set the Y label as speed, and then the title as GUI data, and the grid is enabled. And then for the AX, we need to plot these two charts, wind speed and the wind gust. And then we need to show our ledger. Then we need to set the secondary axis, the name of secondary axis. Here we label like, okay, for the same plot, secondary axis is labeled as AXB. So whatever we type like AXB set labels, it will be accepted for the secondary axis. So the secondary axis name will be pressure in hectopascals. Then AXB plot. That means AXB means use the secondary axis and the same Y axis. The data is data time, and the second date is the Y axis is pressure, and appear this one, and then we are customizing this date according to this format. So if I run this one, now you can see. So the pressure is sharing this axis, while this wind speed is sharing this x-axis. And also here there's an issue. If you check the legend, there's an issue. In the legend, secondary axis data is not appearing. So here we only have wind speed, wind gust, but there's no label for this black color line. We know it's for the pressure, but it's not appeared in the legend. So how we can fix that issue? So if you need to access the secondary axis into the legend, then you have to format it like this for the secondary axis also. So for the first thing is we need to get the lines and their labels. For the first line we have to use AX get legend handles, then the labels for the first line. For the second line also we need to get their corresponding line and their corresponding label from the legend handle from the AXB. So these lines and the labels will obtain from the primary axis, and the lines and labels for the secondary axis also obtained from these two, the second line. So then we need to combine both things and appear in the legend. So then we can type AXB legend. Then we have to specify both the lines which should appear in our legend. So it will be our lines. That means these lines we obtained from this primary axis. Lines plus lines 2 with their corresponding labels plus labels 2. And then we have to specify the location. So did you get this point? For this one is like we using this get legend handles and labels. So it's an inbuilt command. Whenever we run this one, ax.get legend handles and labels is the inbuilt command. Return handles and labels for a specific legend. So if you view the doctrine, it says it returns the handles and labels for a specific object. And if you need to get the handles and the labels, you have to use this command. So it will forward the corresponding line. That means the label in here is a small label, and then their corresponding label into this variable name to the lines and the labels. Then for the AXB secondary axis also, if we have multiple series, we have to pass their legends and handles into a separate one. And then we need to put as AXB, show the legend, then all the lines in the primary axis and the lines in the secondary axis, and then the labels in the primary axis plus the labels in the secondary axis. And this legend should be appeared in upper left. And if we execute this one, now you can see the pressure chart is also appearing over here. Now you can do this small thing like the next one. It's also easy. You can do it fastly. We have some few examples like blue line representing the wave heights. So now instead of pressure, you have to use the wave heights, because if we view our df.info, I can get the df info. So if I get the df info, you can see over here I have variable called wave height. Now I need to view the wave heights also, how the wave heights is changing with these corresponding types. So we have like higher wave heights or the smaller wave heights, or wave heights are not changing. No? Now we try to do this one. A blue line representing the wave heights and the green line representing the wind speed and the secondary axis labels and then their titles. and try to make the wave height as points, not like a line, just use points. You don't need to show the line, try to show points. So try to do this one quickly. So I have the command. So the final plot will be look like this. So in the primary axis, you will have the wave heights in meters, and in the secondary axis, you will have the wind speed. So here you can see the wave heights are appearing in dot format, and the wind speed is appearing in a blue color line like this. So you can see how during these each days, how the wave height is changing. So in May 5, we have the wave height is around like 1 meter. But for the rest of the days, you can see in May 6, May 8, we have like 3 meter high waves. So for that exact thing, you can use this code. Now you need to modify this code. For this plot, you can use and like my AX or something, or you can use any other node. Use AX1. For this one, use AX1 or not. For that thing, you have to use AX. You have the graph name, then for the rotation, you have to use this command, this line. Because now you see the graphing is easy, it's not that hard. Only thing is like you need to go through their documentation. If you understand your data well, then the plotting is just a small thing. That's why in the beginning also I show you different ways how you can view the doctrine. That means you can view the doctrine, just view the doctrine. If you identify the different function, and you need to view what does this function do and how many arguments you can pass, just view the doctrine. So now you can try to create this small chart. It's just a small thing. You can see with the speed how the wave heights are changing. If the wind speed is too high, the wave heights are also going to change.
It can be the wind generator with.
Yeah. So from that the data set, we know the station also we know we are looking for which indication. So we are accessing the data for this specific station.
Yeah.
Yeah. So I can view, okay, this is the station that we are looking for. In over there also we are looking for the San Diego Sea. We are looking for this specific station. And also they show the site sea level and 3.4 meters above the site elevation. and the anemometer height, everything is there. This is the actual picture of that buoy. So we are accessing the data in that buoy. Even the buoy is in the sea, we are accessing the data in that buoy.
How many devices that we? Like, oh, we want to see the.
Huh?
We want to.
What? So the final plot, you need to see the final plot. The final plot will be look like this.
So how many devices are viewing?
I mean,
View back.
we have,
I thought only 2 are working.
yeah, most of the buoys are not working. That's the issue.
Because I propose 2 why for elements.
You can see some buoys are mean like even the guys who are responsible these buoys, you can see.
Only 2 why are working.
Yeah, only two. But
One
those
for-
two things also we have some few data. Only like water, temperature, column height, and those things. We don't have that much data for these two stations.
I propose for elements from China.
Yeah. But you can see if you focus on the US, you can see how many buoys are available in there.
Yes, there is some.
Yeah, that's why they can predict like even if a hurricane or something is coming, they can track.
For the Indonesia, around Indonesia, there were a lot of they had the tsunami project.
Yeah, even in this region you can see.
Oh,
El Nino La Nina region you can see.
for Indonesia, there also small why.
Yeah,
You see, Indonesia had the tsunami alert system.
even in here I think this one is Taiwan.
No, that's what. Indonesia is yes.
Yeah.
How about Atlantic? Atlantic. That's small why. Actually, we had why, but not working.
Yeah, you can see sometimes you can see the guys who are responsible for this.
Or not sharing data or not working.
So here you can see sometimes if the tsunami station is event mode, then you can see it's like masking. This have a high tide wave or wave tide or something.
We use this smartphone for the project.
Because you can see this region, if they need to monitor the El Nino and La Nina situation, that's why I think they put like lot of stations in this region.
Yeah.
That's why all the stations are active. All the stations are active. So you can see some buoys are just still floating in the ocean. There's no any nearby island or something.
So the picture of the moving average for the price. That's moving average. And then to school the time.
Yeah.
There we can do. If you are plotting the daily data.
Yeah, it will be giving the data.
So you have to.
Yeah, but you have to do them.
Yeah, make it more. Yeah, then the more important.
Yeah, that's why the library guys putting apart. So the xarray and then you can.
But for this to now, if you want to just find maybe so here you can just put in. Like you want to that.
Lost there. Yeah. The next thing is like when you are doing something, you need to understand correctly. Yeah. Once you need to go deeper, then you have the next thing is like you have to incorporate this all the languages. Right now we are flowing in separate.
Now everything knows the media.
So at least they know how to create the content like IMSA and how to work in the
What I see is not easy, right? Okay. What I see is easy.
This is just you need to look for the plot and then things when you can find it. And then all the other parameters are
But actually, you have to do that. You have to
for the customization you have to don't mind it wait. Even I am not remembering those things like for the months how much the code. Anyway, anytime we go there and check.
And here nowadays, another thing is keyboard. And symbol, I see. Very cool. They totally different with this code. So that's why I do read one.
If you need to have this plot, we can create like right now in this plot, we cannot zoom into a specific region. But if you need to zoom into a specific region, we have different like to all. That's something like you can interact with the plot. After you prepare the plot, you can interact with the plot.
Yeah, later.
You can zoom into a specific region in your plot. And you can view the actual value of that point.
Already it's under.
Yeah. After you create the plot, you can interact with the plot. The same one is the other one is the
Yes.
whiteboard, so there are the like.
When you put in the
Acting on your channel, you have one. Bokeh, I think this one. This one. If you use this library, you can create interactive plots. Like you can actually zoom into a plot. Right now, you can, if you need to zoom into a specific location, you can zoom in anywhere, and you can play with this one. So if I need to zoom in, I can zoom in. But in these plots, you cannot zoom in and view the actual location. Even if I need to go across the chart, I can go see. Even the x-axis and y-axis is changing. So for this one, you have to use this library.
When you save it, we save the.
Even you can save it as a PNG. It's also why you can save. So here you have the save command.
The save the area.
It will save as a PNG.
That's you wait. When you are zooming, they will
Yeah.
zoom.
Zoom data will be saved. It will be easy. You don't need to do like subscripting into your specific data. Those things.
Another.
You know,
Yes, right. It means the paper.
that's all of us on. Two of us. I don't know. Okay. Look at it. Where's your husband? Don't get them. Where's your husband? No, no, here. I don't know if you want to show the Nếu mà người ta chỉ hiểu số là để thì lan tỏa cái sức mạnh của lòng cô ấy đã cảm ơn như có những lần
So I think we all done by using that thing, right? So this one is another thing you can do like interactive plotting. You can use this one also.
cô ấy chỉ là thật hiện
So for this one, the code is like this. First, you can put like my plot, then the plot size, then enable the twin axis, and then label the axes, and then enable the grid, and then plot the actual data. So first the wave heights will be plotted in the primary axis, and then the wind speed will be plotted in the secondary axis. And then we have to format the date accordingly. Then we will format the date. After that, after formatting the date, we give the commands to appear the both x and y axis legend together in a one legend. So that command is this part. So the next thing is like we can go with the xarray. So the next one is this one. Now we need to know about like NetCDF and the multi-dimension. Up to now we discussed about the tabular data, that means Excel files and the text files. Now we are going to discuss about the HDF files or the NetCDF files. For this one, you know about this figure. From this figure, no, you know, it's like a combination of multiple tables, like different time codes. So that's how this xarray data is organized. I'm not going to discuss about these things like how to create the data and how to load the data. I will discuss from the loading the data. So these are the basic things like I discussed. That's why I discussed NumPy from the beginning. We cannot use xarray alone. We have to use NumPy. So that's why I discussed this one previously, because if you don't know about NumPy, you cannot go along with the xarray. You don't need to, you also need to know something regarding NumPy. That's why I discussed those libraries in order. Because if you don't know about NumPy, then you cannot come into the xarray. Then you need to load these two libraries. Whenever you're dealing, you will see like instead of these two libraries, you will load multiple libraries together. Let me share this code with you so we can go ahead. So also I think you guys also can mark their attendance while I'm preparing this one.
Không, nó rõ ràng là mũi là nè.
Next week, it's the last week for the final. Next week, we continue the xarray and the plotting with NetCDF and NetCDF plotting, data file in next week. Yeah, five years. And after this, last 2 weeks is for the what?
Nó phải đẹp ạ.
Only 2.
Rồi,
Because I think June, the last student exam. And maybe the next week, I will unload the core application form for the next executive team. If you want to be president or secretary or IMSA, you can apply. I will open in next week. Then I will nomination the application list according to the apply posts. Then you can vote. That'd be right.
So you can download the file. I have sent the file out for this one and the data file. You can download it from there.
Let's see.
Yeah.
Yeah, I see.
I think we can recall some memory regarding this one, and we can go for the tomorrow next session. Now we will discuss about these things. Like the first thing is you know about these two lines. It's to import NumPy and xarray. And the next one is okay, how we can create some sample data. We will work with NetCDF files, but we need to know about the file structure. If you know about the NetCDF file structure and their metadata and the corresponding like variables and those kind of things, you can easily manipulate the NetCDF data. For this one, we will create some sample data. So you know, I discuss about this one, like we discuss NP render. We discuss about this one during the NumPy. What's the main purpose of this one? And it will create some random data set with 5 by 3 by 4. That means I will have 4 tables and then three, the 5 columns and 3 rows with 4 different time steps. So, and the values will be filled by using this one because NP random value is ranging between 0 and 1. Then I need to add some values to that one. So here I am creating some sample data set. Like you can imagine this data as a temperature data. So now I have some sample temperature data. That means I have these 4 different time step data. Then how I can convert this data, that here I only have, so if I enable this variable thing, you can see from this side I have the data. It's in ND array. That means we discussed about ND array during NumPy. It's in NumPy format. How we can convert this one into the xarray format? So to convert this one, we can use xarray data array, then our data format. So if we run this one, now you can see the temperature is converted from ND array to the data array. Now, if you see something like data array, that means data is formatted in xarray data format. That means a time series or something. So for those data, you can see when you view the temperature data, here you will see some different things like dimensions, dim 0, dim 1, then dim 2, dim 4. Likewise, you will see something like this. But when you are viewing this data, typical data, you cannot see some names like this, some variables like this. You only see array, then your data. But in here, it's totally different. So now we have also coordinates, index, attributes. So these typically the structure of the NetCDF. So you know, when we discussing in the NCL class, we discuss about much more detail like coordinates, about indexes, and then the attributes. So right now we only have sample data. Then we have to name our dimensions. How we can name the dimensions? So here it shows like we have dim 0, then dim 1, dim 2 as 5, 3, 4, the random numbers. But we need to name those dimensions right now. So when we are going to name those dimensions, then we have to type data, then the dims as time, latitude, and longitude. Then we execute like this, you will see those dimensions are named. So for the time, how many dimensions we have? We have 5 times. And then for the latitudes and longitude, it will be like 3 by 4. That means 5 tables, 1, 2, 3, 4, 5. For each time steps and latitudes, we have 3 columns, three rows, and we have 4 columns. Then we need to know about pandas. That's why I discuss about the panda also, because then we need to know panda from the NumPy to the panda, then the xarray. Then we will create some time series because we don't have some time series data because we have like 3 different times. Now we need to set those as time. So from here I will generate random date to assign into this data set. Now I have 1, 2, 3, 4, 5 time steps. So here the main purpose is from the panda we have a function called date range. From there we can generate some random dates in between, where in between these 2 days with the period of 5. So it will be 2018 1, 2, 3, 4, 5. So then we have this times. If I view times is in date and time index. So then also I know, then I have latitudes and longitudes. So I need to specify, okay, these 3 latitudes are these latitudes levels and these longitudes are these longitude levels. So where you typically weave in the NetCDF file, let me open this simple NetCDF file. You will see from Panoply, I can load this data. So from there you will understand what I'm talking about. So if I load this simple data here, I have the metadata and all the latitudes and the longitudes. So here, if I view this, analyze this T and go for the plot, it will generate this plot. and from the array I can view. So these are the different latitude levels and these are the different longitude levels. And you can see for each grid, that means we have grid. So each grid we have values. So you can see this is the entire data set. Even you can convert this one into Excel file and you can see. Now we are creating a file like this. So for that thing, I need to specify the latitude levels and the longitude level. Okay, now I use numpy line space. We discussed about this one. That means if I use line space, what will happen? So it's going to create with the start point and end point. I can specify the time interval. So between those 2 points, it will create equally spaced values. So now I am going to create 4 latitude intervals and longitude intervals as lats and lon. Now I need to assign those variables as my coordinates, because from here you see I don't have coordinates. It's like 0. Now I am going to assign the coordinates and view this data. So now I have in the coordinates I have time, latitude and longitude. Previously I don't have that thing. Then I need to discuss about the attributes. Okay, I have values, but I don't know what those values represent and what are the units for those values. So that thing we can access for the variable, then the attributes. Variable attributes, then we can specify, okay, for these attributes, the units are in Kelvin. And then standard name is air temperature. So if we execute this one, it will create 2 different attributes. That means these values are the temperature values, air temperature values, and the unit is in Kelvin. So we are just creating a file, not like reading a file. But when you read in the file, you will need these things. These keywords, the same exact keyword which you will see. So now we are creating the attributes. Then we can do like calculation. Okay, now if we need to convert these temperature values into Celsius or something, how we can convert? The simple thing like temp, then minus this one. So you can see it's affected for the entire table, all the tables. But you can see attributes are good. Here, the attributes are good. We discussed about this one also during the NCL session. When you do some corrections or the calculation like multiplication or something, the attributes will go. Like attributes will be reset. Then you need to retype those attributes again. Okay, then if we need to specifically select a specific time state of our data, because we know that NetCDF files are time series data. We have multiple table and we only need to access first table, first time state. So how we can access the first time state if the time is there? So this is the command that we can use. Like then we have to specify our data, the name variable name of our data, then dot SEL. That means select. Simply select SEL, then select this dimension. That means dimension name is time, because in here I have this time dimension. In the bottom you can see, in the top you can see I have time dimension, and the time I have, the values for the time I have from 2018 1 to 2018 5. So if I need to select that specific time frame, I can use this command. Now you can see this thing is subsetted. Now you don't have the time dimension. Now you left with latitudes and longitudes. So now that 3-dimension data is converted into 2-dimension data. So you can see for this one, it's not affected. You can see the time is in the date and time format, latitudes are in this float format, and the longitudes are in this format. Then we have some other commands like interpret and the select. So how we can use these commands to load the data. For this one, if we need to interpret some point, we can use temperature.interpret specific longitude level and the latitude level. So it will give you all the 3 time series, time data for that specific latitude and longitude. So now you can view each and every time step, what are those values. So those are some basic things. And also you need to know about this one, the slicing, how you can slice your data. When you're dealing with the NetCDF, you need to slice according to your specific latitude, longitude, according to your specific time period. You need to know how you can slice. Like if you download the entire data, like the entire global data set, now you need to focus on a specific region. So how you can slice into that specific region. And even if you need to reduce the time dimension, how you can select the specific time steps. So the next thing is you need to know about those things. For that thing, you can use this select command. Temp.select, you can extend this one. You can view the doctrine. In here, we have indexes and the methods and the tolerance. So if you go into the bottom part, you will see some examples also, how you can use this slicing command. You have some examples also over there. So in typically, if you need to slice, select, you can either select some time steps and longitudes and the latitudes, but you need to keep in your mind, you have to check about these xarray, these dimensions first. You cannot rename this dimension name. It should be appear accordingly. So before I print this one, if I the new line, move it over here and I view the temp data. So you see time, latitude and longitude. So now I need to see only these two time steps. I need to select only these two specific time steps. And time steps should be between these specific longitudes and these specific latitudes. Now I'm going to slice from that NetCDF file. So to slice that thing, I can specify, okay, for the time equal, then slices time into these specific time intervals.
So those specific times.
Yeah, those specific times will be selected from that NetCDF file.
Not range.
You can specify.
So that
Yeah.
individual time.
Yeah. Then you can specify the range of your longitude levels and also the range of your latitude levels. So if you execute this one, you will see now it's executed. Like for this one, it's not the different times, it's the range. Right from the 1st of January to the 1st of 3rd of January, you need to in between those two range, you can see now it slices. Now you can see here you have 3 time steps, and for the latitudes and longitudes you only have 2 and 2.
Select them separately without the range. Maybe I want only these two times, two times, not the range. I want on the first and part. It was
Yeah, it's possible. Because if you need to select something like that, then you have to remove this slice and specify the entire time period, but separately. Into separate files you have to load. And then you have to combine them together. Yeah. Yeah. In the beginning, we discussed about this one, how you can select only one time step. Likewise, you have to select the one time step and then you can combine. Then the next one is like location. So we discuss about this one also. Also, you can use the loc. We discuss about this one during pandas. If you need to specify like iloc, coloc, that means for a specific location, if you need to view the data, you can use this loc functions also. Then if you use loc, then the time is specific time frame. Then also you can extract that data, like same like the select command, but you can also use the loc command. Yeah. So let me copy this command into the nearby so we can view the side by side difference. So we can copy this command and we can try to move.
Okay. After this.
So now you can see the difference. Actually, there's no any difference. It's like the same thing, but you can use different ways. The same thing, but you can access using different commands like location or the type. So if you use loc, you can give whatever the thing in here. Otherwise, you have to specify the dimension. That's the only thing.
I am interested.
What?
Same time.
Yeah, here I am specifying, okay, select from this like dimension. Here I am not specifying the dimension. You can see I am not specifying the dimension. I just giving the type. Now it will select the specific data.
Last say, I asked you to, what are the different?
Two difference using the location and this one.
You're very in log. Log is automatically understanding what you are.
So that's the two different things. Those two things. Then we can discuss about this one, like using this one, how to open the NetCDF data, and then we can read those things like the actual data. So if you have NetCDF files, just come with those files, so we can try to read those files. So next thing is like we are going to read the NetCDF files. I have seen some sample data set. We can read the sample data set. So if you read those data, you will see different attributes and you have different things over there. So from the next class onward, we will discuss how to load the data, and we can go for the plotting.
Now you can go.
So